All right, this is EET112 Lab1, and I was just going to go through some of the assignment just in case you had trouble going through the button pushes on the scope. So right now I've got the function generator set up for the 50 kilohertz 10 volt peak to peak sine wave with 0 offset. It says on the screen of the function generator, it says 0.0 millivolt DC offset, and of course we're in high Z mode. Okay, so and I've pushed the default button on the scope, and now I'm going to turn on the function generator, which is hooked up to the probe as shown in that photo. Okay, so you should see something like that. And so what this is you know, we're triggering on the sine wave, but we're only seeing a piece of it. Now in the instructions, it tells you to push this channel 1 button here. And then what do we do? Get down to that. Okay, so now what we want to do is adjust both our time scale, which is the x-axis, and the voltage scale, which is the y-axis. But before we do that, we want to notice that on the horizontal time, we have 1 microsecond per division, and that's shown right here, 1 microsecond per division. So each of these grids represents 1 microsecond of time. And the vertical scale over here, 1 meaning channel 1, is at 1 volt per division. Okay, and this little, that yellow arrow there with the 1 on it means channel 1. That's where ground is, or 0 volts. All right, so now what do we do? So we're supposed to adjust the horizontal to be at 5 microseconds per division. So 2, 5 microseconds per division. So now it looks like figure 11. But now notice we've got our sine wave, but we're clipping it at the top and the bottom, and we don't want to do that. So we need to reduce the gain of the vertical, or the y-axis, by turning the vertical knob down 1 notch to 2 volts per division. So now notice here we have 2 volts per division, and over here we have 5 microseconds per division. Okay. And now you're asked to measure the waveform's peak-to-peak voltage. And you can do that 2 ways. One is you can count the number of grids from the bottom to the top. So you're asked to do that, and then multiply by the number of volts per grid, which is 2 volts per grid. The other way is you can hit the measure button here, right here. And now you see down here we have peak-to-peak at 10.4 volts, and also the period of the sine wave is about 20 microseconds. So you notice one thing, that even though I have the function generator programmed for 10.0 volts peak to peak, we're measuring a little bit more than that. Okay. All right, well that should get you going. Now the other thing, I'm going to go off script of the lab document now and just talk about triggering for a moment. So the way this scope works is it first has to trigger on the waveform. And then once it finds a trigger point, then it's going to follow it, and then it's going to paint in the whole sine wave until it needs another trigger point, and then it's just going to keep repainting the same thing over and over. And because it's a periodic waveform, it appears to be stable here, right? And so the way to figure out is, where is it triggering? Well, this arrow on the right tells you where it's triggering, and then also the blue arrow. So if you follow those together, you'll see that it's triggering right in the center here. Now, I can move this trigger with this knob over here. Now watch what happens when I move it up. You see how the sine wave appears to be moving? Because now it's triggering on a different spot. If I move it all the way up here, now notice it's triggering right at this point. And that's why the sine wave appears to be moving, but it's just where the scope is triggering. And if I go too far above this, it's going to lose. Now it can't trigger because I'm telling it to trigger too high. So I'm going to move it back down. And it works the other way. If I go down, then notice it keeps moving to the right until I go too far and it loses the trigger down here as well. So triggering is important. Now, if you want to get back to the exact center, you can just push this button and it'll automatically go back to the center of screen. Now, you can also move the horizontal. So this knob here is the horizontal position. Notice it's going to move the blue. So as I move that, you can see that the trigger point, again, you follow this over to where it intersects the blue arrow. So it's triggering over here now. And then again, I could move the trigger from there and it also tends to move. Now, if I want to get back to the center, I can click both knobs. And now I'm triggering back in the center again. Okay. You know, the other thing about the trigger is you can go to the trigger menu by hitting this setup, and then these soft keys down here have other functionality. So we're triggering right now on the rising edge of the sine wave. If I click this button to go to the falling edge, notice now it's triggering on the falling edge of the sine wave. So you can trigger on either one, rising or falling. And if you want to get rid of these after you've chosen, you can just click the select button. But one thing I found about the select button, if you don't push it exactly straight in, sometimes it'll get rotated ever so slightly and it'll choose the option that you didn't want to choose. So when you select things, be sure you push straight in and try not to rotate when you're pushing in. Okay, so that's the trigger menu. The other thing is I wanted to talk about averaging. So again, notice 10.4 volts peak to peak. Now, if I average this waveform, what that's going to do is it's going to tell the scope, let's look at several traces and then average them together. Okay, you can do that by hitting the acquire menu, and then over on here on the left, acquisitions, you can pick average. When you pick average, you'll see the number of averages it's using. So 16 is the default. Now, if I select that, look what happened to my peak-to-peak voltage. It appears to go down. Now it's down to 10.24. The reason for that is when you average, you're effectively getting rid of noise on the waveform, because there is noise involved in any electrical signal. Because it's periodic, the more you average, the more you will effectively get rid of that noise, because the noise is random. And so if I pick enough averages, let's go to 256, for example. Select it. Notice it's going to come down even more. Now, it takes the scope some time to do that averaging. And so one effect of that, if you have averaging on, notice that if I were to move the trigger, for example. Like before, I wanted to move the trigger level up. Let's do that. You notice the waveform doesn't move. It's going to take it some time to do the averaging before you're going to see it move over very slowly, because it's doing 256 averages. So if you want to see the trigger move quickly, you need to take off averaging. So, and you can do that by going back to normal. Okay. Now the other way you can do this is, let's say I did have averaging on, and it's doing this 256. And now I move I'm going to put the trigger level back by pushing. And now let's move it quickly. Now if I hear clear sweeps, that moves it quickly to where the trigger point is, because what clear sweeps does is it says, throw out all the previous averaging and let's start over to do our averaging. So then, you know, it would trigger immediately to where the new, trigger point is. So my point is averaging is really good to get rid of noise, but when you use averaging, you have to be careful, because if you have a lot of averaging on, the signal isn't going to move instantaneously. It's going to take the oscilloscope a while to do all the averaging and then display what it is you want to see. So a lot of times, if I'm first trying to acquire a waveform, I will make sure that averaging is off. So at normal, I'll get my waveform, what I want to see, and then let's say it's a noisy waveform, then I'll turn on averaging once I've got it triggered and I'm happy with the way the waveform is looking on the screen. Okay, that's pretty much all I want to say about this. Let me know if you have any questions.